So till now we have discussed about the history of power system, history of power system automation, and we have also seen the current structure of the power system network and why there is a requirement for the smart grid technology. We have also discussed the difference between IT and OT and why the convergence of IT and OT is required. Now, let's start the discussion about the smart grid technology. So, let us see the definitions of smart grid technology which are given in literature. So, we'll start with 4 R's of smart grid, that is resilient, reliable, robust, and reconfigurable. So, if the power system network is resilient, reliable, robust, and reconfigurable, it means that it can be considered as a smart grid network. Now, what is resilient? Resilient means if there is a fault or any abnormal condition in the power system network, then the system can recover quickly from that abnormal condition. So that capability is called the resiliency of the network. Now, second is the reliable. Reliable means it offers 24/7 supply to their users. It means that we will be relying on the power system network for providing the supply without any interruption. Now, third one is the robust. Robust means the system should withstand small oscillations or any abnormal behavior without any issue. So that means that if the system is able to handle any swing or any oscillation without any challenge, that means the system is robust. Then the fourth point is reconfigurable. Reconfigurable means that if there is a problem and the set of power lines are out because of any fault, system should reconfigure itself to restore the power to the connected loads through alternate route. So this will be done automatically so that the user is not impacted because of fault in the system. So in that case, your power system network topology will change and it will be reconfigured in such a way that the power is restored quickly to the affected users. Now let's see the various definitions which are given in the literature. So as per James Momo, the definition is that a smart grid is an advanced power system network having two-way digital as well as electrical power flows, capable of self-healing and adaptive, resilient and sustainable, with foresight for prediction under different uncertainties. It is equipped for interoperability with present and future standards of component devices and systems that are cyber secured against malicious attack. So the key points in this definition are two-way digital communication, means the devices which are there in the field will be able to communicate to the server, as well as server will be able to send control commands to the devices. So we will have two-way digital communication as well as the electrical power flow. Two ways means the power can be flowing bidirectional in the power system network. It has a capability of self-healing, means if there is a fault, the system will address that fault automatically without any external intervention. So that means self-healing. Now, adaptive, resilient, that we have discussed. Sustainable means it can withstand any abnormal condition without any problem, and it will not break when there is a problem in the system. Foresight for prediction means the system can predict any abnormal condition well in advance and take action accordingly to avoid that abnormal condition happening in the system. It is equipped for interoperability, means the data is interoperable so that the information can be shared seamlessly across the network. It should be cyber secured because the moment we touch IT and communication network, there is a risk of cyber attack. So system should be cyber secure. Now other definitions as given by the National Institute of Standards and Technology, that is NIST USA, it says that modernized grid that enables bidirectional flows of energy and uses two-way communication and control capabilities that will lead to an array of new functionalities and applications. IEEE definition says that a smart grid is a large system of systems where each functional domain consists of three layers, that is power and energy layer, the communication layer, and IT layer. The layers 2 and 3 above are the enabling infrastructures that make the existing power and energy infrastructure smarter. Now in this definition, the important component which is missing is the intelligence. How you will build intelligence? It is not only the activity of IT system, but it is an integrated activities which includes IT, communication as well as power layer. So all these three layers with some inbuilt distributed intelligence will make the infrastructure smarter. Now why there is a need for a smart grid? We know that the generation happens at the generating station, then using power transformers it is stepped up, and through transmission lines it reaches to the distribution network and then to the various loads. Now what is the challenge in the current distribution of the power system? The reason is that we have now wide geographical spread of the power system network. So when we have the power system network large in size, it means that monitoring and control of that power system network is a difficult task, and with the help of our conventional resources we cannot maintain the proper monitoring of that large power system network. We have large number of interconnections because of political, economic, environmental or reliability or stability based reasons, and this will again cause some issues because when you have large interconnections, the power flow needs to be properly monitored and controlled in almost real-time environment. Rapid growth in the demand of electricity. So the demand is keep on increasing. When you see the time horizon of the demand, it is not continuous. It is sometimes high in a particular time period and then suddenly it goes low and then again becomes high. So the growth is there, plus the spread of the growth is also different, where we have to have continuous monitoring so that we can address the resource overloading. So all those things are possible when we have the proper monitoring. So the demand growth also needs to be monitored effectively for the healthy operation of the power system network. Now power system network components are being operated closer to their design limit. So say take the example of transformers which are there in the distribution system. The load has grown drastically, and now the transformers are almost overloaded at the distribution level, which is creating frequent breakdowns and lot of problems. So that also needs to be addressed with the help of new technologies in the smart grid area. High penetration of renewable energy sources, this is causing intermittency, then again relay coordination because bidirectional power flow is happening now. It will also create power quality issues. It will also create system stability related challenges. So to address all those things, we need to have the smart grid resources to be deployed so that we can have the better utilization of renewable energy sources. Another point is that we have a competitive electricity market. That means that right now in most of the cities we have only one electricity supplier, but in future we may have possibility to have multiple energy suppliers in a city, and you can choose the supplier similar to what we have in case of mobile communication. So we have mobile number portability. Similar to that, we will have the power meter portability. So in that case, we need proper monitoring and strict regulation, which is not possible with the conventional power system monitoring resources. We need to deploy smart meters and associated advanced metering infrastructures to have the proper monitoring of the system. So these are the some of reasons which say that we have to move now to better monitoring and control regime, and that regime is possible with the help of the deployment of smart grid technology.